Hi, welcome to the Shoko Math Lab Fun Probability Problem Solving section. And today's this problem is a little bit long. We have 4 parts. So let's take a look at the first 2 parts, and then after we finish the first two, then let's take a look at the second parts here. Okay, so this is about two boys play the basketball, and so they will take turns shooting and stop when a basket is made. Player A goes first and has the probability of the P1 of making the basket of any throw, and the player B, who shoots seconds, has a probability P2 of making a basket. So the outcomes of the successive trial assumed to be independent. So the first ones here, the first part of the problem is ask us what is the frequency function for the total number of attempts. Basically, I want to find the PMFs here for the total number of the attempts here. Then the second part we're going to do is try to find the probability that the player A is winning, player A wins here. All right, so like I said, this problem is a little bit long problems here. We have 4 parts. So let's take a look at these 2 parts. Now, after we find these 2 parts, let's take a look at what are the next 2 parts about. All right, okay. So let's go ahead and solving the first two here. All right, let's start. And before we find the PMF, so let's try to take a look at what, do a little table and let's see the pattern about these problems here. So, okay, so let's say the A has the probability for the P1 to make the basket, right? And the B is with the probability P2 to make the basket. Okay, so now let's take a look here, right? So the numbers attempts to make the basket. So let's take a look. How about if the first time, n equal to 1, A made it. Okay, so A made it. So this is N equal to 1, right? Okay, so how about the second time? The first one, A, did not make it. And then here the B made it. Okay, so like in here we said A made it. Okay, so let me use different colors here. All right, so A made it. Now the B made it, but then the first time A not make it, right? Okay, so now let's take a look at number 3. The 3, that means the A start did not make it. B did not make it. Now finally A make it. Right? So this is like an ABA. So the finally A is here, then they did not make here. Okay, let's take a look at one more. Maybe we'll get a pretty good idea. So this is 4. 1, 2, 3, 4. So here the A, B, A, B is here. As you can see now, the B make it. Then the A, B, so this is not, right? So let me color it. So A, and B, B. Okay, so as you can see, if the B wins, the number of attempts is an even number, it's 2, 4, 6, 8. Then if A wins, right, so the number of attempts is an odd number. So this definitely will help us. So like in here we say, okay, so what is the probability A going to make it? It's P1s, right? So what is the probability right now that B going to make it? So this is 1 minus P1 and times B is P2. Okay, let's take a look at 3 here. So this one's A not make it, B not make it. P1, 1 minus P2. Then A made it. All right. So now this one's here, we have 1 minus, so B, A did not make it twice. So 1 minus B, 2, right? Then 1 minus what? 1 minus P2 not make it. Then times P2 here. Okay, so I know that, remember that, right? So when A wins, so the A will be what? Will be winning at an odd number. And when B wins, will winning at the even number. So if we can do one more, so make sure we got a good idea. So here I know that A going to win here. So you will have A, B, A, B, A. That's right. So they did not make it, not make it, not make it, not make it. And finally here, they made it. So what is this probability? This will be 1 minus P1 to the square, 1 minus P2 to the square, then P1 here. Okay, so now let's find the PMF. Okay, so let's the part A is here. Based on these patterns here, so let us assume the probability the X is equal to K here. Okay, so where K is the numbers of the attempts. Here the winners, right? Okay, so now I know. Okay, so when this one's here, we know the P the T equal to K. So the P the X equal to K. So I know it will be okay. Let's take a look at the A wins, right? So it's 1, 3, and 5 here. Okay, so I know the K if it's an odd number. So the 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 probability it will be 1 minus P1, all right? So it's a K minus 1 because the last one, A has to win. Then divided by 2, and then this is 1 minus P2, K minus 1 divided by 2, then times P1, right? So this is a K is odd. So at the time, or you can say that is the probability A going to win. So the same things here. If K is even, so what is this PDF or PMF will be? So it will be B wins, right? So this will be 1 minus the P1. Okay, so it's an even number, it's a K over 2. And then the same thing is 1 minus P2, the K over 2. Then the last time is the P2. So this is if the K is even. Okay, so this is the, okay, so this is here, right? So this is my PMF. That's all you can say. This is the frequencies here. All right, so now the second question is they want to ask you is what is the probability the P going to win the game? A going to win the game here. Okay, so it's A wins. Okay, so we said A wins here. So let's take a look. So that means A could win on the first try, right? So this will be P1. Okay, or A could win. So remember, this is the first trials, right? And or A could be on the third one. So that will be the 1 minus P1, 1 minus P2, then P1. Or A could winning on the fifth ones, right? So it's 1 minus P1 to the second, 1 minus P2 to the second P1 here. Okay, then they dot to the infinity, right? Okay, so now how do I find it? So here, this is the A win on the third, right? And this is A win on the fifth attempts here. All right, so now let's try to find the probability. How do I do that? I can take the P1 out, factor the P1 out. So then this is 1 plus 1 minus P1, 1 minus P2, plus 1 minus P1, 1 minus P2, the square, and then plus 1 minus P1, and so if you continue, this will be 1 minus P1 to the, the 1 minus P1 to the third, 1 minus P2 to the third, and the dot, 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 right? Okay, so now inside, okay, if you take a look at the inside here, this is a geometric series, right? So this is the infinity geometric series. And for the geometric series, what is the R for the geometric series? The R's here is what? For this geometric series, R is 1 minus P1 times 1 minus P2. I know this number is less than 1, so I know this geometric series is a convergent. So also I know that if the R is a convergent, then the series, the geometric series, the sum of a geometric series will converge into what? Will converge into 1 over 1 minus R, right? That's what we learned in our algebra or the calculus. Okay, so now in here I can just summarize it. So this would be P1. Then I use the geometric series times 1 minus R. So my R is the ratio. So this will be just 1 minus P1 and 1 minus P2 here. Okay, so this is the probability A going to win the games here. All right, so the first two parts is not too bad. Just you just need to know the geometric series, how to find the sum of a geometric series. All right, so now let's take a look at the second two parts for this problem here. All right. All right, so the second part, we have two parts here. So they say to observe that A wins if either he makes a basket on his first trial, or if neither boy does and A is the first to make the basket afterwards. So they want us to prove this conditional probability that A is the first to make a basket after neither boy makes his first attempt is the same as the probability A win show. So first things they want us to show the P win is equal to is the P makes the first one plus the neither make the first attempt times P wins here. All right, and then we want to try to see if we solve the probability of the A wins here. So remember in the part B, the previous part, we already solved the probability of A wins. And then let's try to see if we use this conditional probability concept will match the probability of what we solved before. Okay, so the second part is it's kind of clear, it's kind of intuitively true. If the probability A is bigger than the probability 1, then the A has benefit, advantage of winning. That's kind of like obvious, right? But also the advantage of the A wins because A starts first, right? So then here they want us to find is what is the condition that A is more likely to win than B. So if you say the B, getting the shot is 0.25, so what is the player A's the probability to make the basket? All right, so now, and let's take a look, see how do we solve these two problems here, right? Okay, so let's start to work on the part C here. So part C is tell me, so they said for the probability A wins here, basically you can say it's a probability A wins at the first attempt, right? Plus probability neither make the first attempt, and the time then Afterward, probability A wins. So they want us to solve the probability A win. If I consider this, it will be the same as what we solve for the part B. So let's take a look at this one, the probability A win at the first attempt. All right, so what is the first attempt? That means this one is the probability P1. Okay, so now the plus, the probability neither makes at the first attempt. So this one here will be what? 1 minus P1 times 1 minus P2, right? So this will be the 1 minus P1 times 1 minus P2, then times the probability later the A will win. Okay, so now in order to solve the A, I can just I can minus this term. I can minus 1 minus P1 minus, I can move this term to the left-hand side. So that means the probability A wins minus 1 minus P1, 1 minus P2, probability A wins, and they equal to P1, right? Okay, so now you can factor the probability A wins here, okay? So now when you factor out, it will be 1 minus P1 times 1 minus P2 equal to the P1. So you divide these constants both sides. So probability A wins is going to be equal to 1 minus P1 times 1 minus P2 to the P1. And this answer match exactly what we solved it in the part B. If you remember here, okay, so that's what exactly match. So that's why we proved it. Okay, so the last ones here, they want us to show what the conditions here. All right, so we know the A has advantages here. So we want to see what is the condition more likely to win than B. Then identify, so if I know the probability for B to get the basket is 0.25. Now, what is at least A is the probability to make the basket? All right, so let's take a look how do we solve these problems here. Okay, so in order to approach this problem, the first I want to figure out what is the probability the B will win here. So now I want to set probability of the A will win greater than B will win, and then try to solve what the condition, the P1 has to be. Okay, so the probability of the B, so I know the B, if in order for the B to win, we have to have in the even numbers, right? So like in here, so we know the first time B can win is in the second time. So it's 1 minus P1 times P2. Then the second one is at the fourth time. At the fourth time, that means the A has to fail twice and B has to fail once. Then finally, B wins. So this is the second time. So this will be so this is the second time. This is the fourth, right? And then if we take a look at one more, so we'll see this one's here, then the attempt number 6. Okay, attempt number 6, that means what? That means 1 minus P. So A is going to fail 3 times. Then B going to fail twice. Then finally B succeed, right? So this is the probability of the B will win here. So if you take a look here, this is a geometric series also. So let's factor out. Let's see which one we want to factor out. Let's factor out 1 minus P1, P2. So the first term will be 1 plus. All right, so P1, P2. So I have 1 minus P1, 1 minus P2. Then plus, then here it will be 1 minus P1 to the square, 1 minus P2 to the square, and da. So this is so the R here is the same, right? So R is 1 minus P1, 1 minus P2 here. So by using the geometric series summary, so I know the probability of the B going to win here. All right, so the probability B going to win going to be 1 minus P1 times P2 means 1 minus R. So it's 1 minus P1 times 1 minus P2 here. So this is the probability B going to win. So we said, okay, if the, what is the condition A have, must have in order to win, right? So we said we put here is probability A wins has to be greater than the probability of the B wins, right? So let's see what is the condition the P1, P2 have. So probability of the A is P1, right? So this is 1 minus P1, 1 minus P2. And it has to be greater than 1 minus P1, P2, then 1 minus P1, and 1 minus P2. So as you can see, right? So as you can see, they have the same denominator. So in order for this inequality to be true, so that's why the numerator, the P1, has to be greater than P2, so 1 minus P1 times P2, right? Because that is the probability B, right? So it's 1 minus P1 times P2 here. So it has to be here. So now this one's here, I can factor, I can FOIL it, use the distributive properties here, greater than P1. All right, then I can move this term. So it's P1 plus P1, P2, greater than P2. Then factor the P1 out, 1 plus P2, greater than P2. That means the P1, the condition P1, in order to win, P1 has to be greater than 1 plus P2. So P2 over 1 plus P2. See. All right. So now, okay, so now we can, the problem say, how about if the P2 is equal to 0.25 or the P2 is equal to the 0.4, then what is the P1 we must satisfy here? Okay, so remember this condition, right? So P1 has to be here. So under the P2 is 0.25. That means I have to make sure that if a P1 has to be greater than 0.25. Okay, so it's 1 plus 0.25. So if you put into a calculator, so this is 0.2. So it's kind of makes sense, right? So as long as the chance P1 is greater than 0.2, because the P1 has the advantage of start first, then as long as the P1 greater than 0.2, even the probability B wins 0.25 because of the advantage P1, the A start first. So I only need a 20% chance to make the basket, and then the A has a better chance to win. So the same things here for the P2s here. When the P2 equal to 0.4, then I know the P1 has to be equal greater than 0.4, 1 plus 0.4. Okay, so this one's here, this will be equal to 0.2857. Right, so that is the same with because of the P1 has the advantage to start first. So if the B, the probability making the basket is 0.4, then A has to be at least is about 29% to make the basket in order to win the games here. All right, that's it. That is about this problem. I find it's very interesting, and also you applied several concepts, conditional probability, and even talk about the geometry series. So I hope you enjoy these problems here. Okay, looking forward to talk to you in our next problem solving sections here. Bye. Have a good day.